The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Hello and welcome back to Element 14 Presents. I'm Caleb, and in today's episode we're going to build a DIY USB helicopter collective joystick control for flight sim.
Amazing hacks. Inspired designs. Each week, Element 14 Presents brings you innovative projects using electronics, engineering, and more.
I really enjoy flight simulators and have a basic control setup for airplanes, but I also like to fly helicopters. And they have a different control setup than a standard airplane does. It's called a collective. It changes the pitch angle of the main rotor blades collectively, therefore increasing or decreasing the total amount of lift from the rotor. Basically, it's the control that makes the helicopter go up and down. It's typically located on the left-hand side of the pilot seat, and it's a lever that moves up and down. I decided to build one of these because they are not cheap to buy. The cheapest I have seen is about $350, and they just go up from there. I've seen others on the market well over $1,000. So today, it's DIY time. There are several things that we need to solve in this build. It needs a lever that travels vertically to transfer rotational movement to an encoder, hard stops at the top and the bottom of travel, and some sort of friction adjustment so that when I let go of the control it stays in place. We're also going to add some switches and buttons to the control handle. All of this will connect to an Arduino Micro that has an Atmega 32U4 microcontroller on it that provides in a built-in USB device module. This, along with a specific library, will allow the Arduino to show up as a joystick when plugged into a computer via USB. Then all we have to do is write some code to transfer the I/O to joystick functions. Let's have a look at all the parts that are involved in this project. First bit is a piece of 1 3/8 aluminum tube for the actual handle. It's going to be the lever. We've got some pillow blocks, some bearinged pillow blocks with set screws in them. These are going to be great for holding up the pivot joint that the lever will ride on. We've got an Arduino Micro, and this has the Atmega 32U4 chip on it, which allows the host operating system to see it as a human interface device, which, pick it up like a joystick. And I'm using every single I/O port on that, so we're going to add an MCP 23017 I2C GPIO expander. It's quite a mouthful, but it's going to give us 16 extra GPIO ports. We've got the nice Borns encoder. This is an absolute encoder, and this is the device that's going to read the rotational value of the lever when it gets pulled. We've got another rotary encoder, which we're going to put on the handle with a cluster of buttons and switches up there just for some extra input. And let's see, we've got my favorite buttons. You probably recognize these from the Raspberry Pi music player build. I just can't get enough of these. I keep them in my Element 14 shopping cart all the time now. And what else? Got some toggle switches. Gonna have to do some weird code with this because I couldn't find spring return to center. Both positions will do the same function, so it'll be like button 4 one way, click it again, button 4 again. But it just feels really nice to have that toggle on or off position. And we have the 5-way hat switch, this tiny little guy here. They call it a 5-way because it's got up, down, left, right, and then click straight down. But if you read it right in the microcontroller, you can get 9 positions out of it because up, left, down, right, etc. all have a value if you read it right in the microcontroller. And of course, a whole slew of 3D printed parts, which I'll show you real quick here, but you'll also see it throughout the build, so have a look at these. For this build, I was lucky enough to find the more complicated parts already built in 3D, so I could just import them into the project. These were the pillow blocks and the encoders and the toggle switches. I already had the momentary switches from the music player build. In order to transfer vertical movement to rotational, I designed this bracket to connect the handle to the main pivot shaft. It's going to clamp to both of those. The pivot shaft is supported by these two pillow blocks, which will keep it in place and transfer the rotational movement to the encoder. Next up are the hard stops. I need the lever to move approximately 40 degrees from horizontal, but I want it to stop there and not go below horizontal. I thought of a few ways to do this, but as I was thinking about how to solve the adjustable friction, I figured that I could build them together and solve both at the same time. This knob will screw down and clamp these plates down, adding friction. The screw that controls that can act as the hard stops as well. I didn't want PLA on PLA for friction, so I'll cut up some old chemical bottle that's made of HDPE and glue it to the 3D printed plate so it won't wear as fast. Might have to add some grease to that if we need to during the build. Since it only rotates 40 degrees, that's not going to be enough data from the encoder to make it smooth. According to my calculations, I'm going to need about 6:1 ratio on the pivot shaft to the encoder. I made this gear kind of an odd shape to reduce the print time. I hope that works. And then for the handle. I looked at a bunch of images of real collective controls and came up with this as a design. It's not a replica, it's just what I thought would work well for me. There's buttons on the bottom for trigger type control, and the rest on the top will be controlled by the thumb. Let's print all this stuff out and get started. First things first, let's build the mechanical side of this first, because I think it's going to be the most difficult and maybe the most fun part of the build. And then once that's out of the way, then I can focus on the code and electronics. So let's get at it. Before we get started, I forgot to show you this piece. I want to show it to you. It's the base plate that everything's going to mount to. It's a piece of acrylic. I took it down to my makerspace and cut it out on the laser so all the holes and everything are laid out exactly where I need them. Let's peel this paper off so we have some nice shiny acrylic to work with. First thing that we need to do is get the HDPE glued onto these. Let's go for it. I just went for my glue and put it all together that I don't have any glue that is going to adhere to the HDPE, but I do have some really thin, super strong double-sided tape. It's like double-sided duct tape used for flooring that I got while I was doing a job at one point. So maybe I'll use that. It's really thin, it shouldn't even be an issue. Okay, we got all four sides done. Now moving on to assembly. Well, it all went together and it looks like it's gonna work. That's awesome. You can see that its gravity is making it fall back down. Add some friction here. A little bit better, a little more. Add some more. Oh yeah, that'll be great. Give it another crank. Yeah, perfect. All right, well, there it is. Nice, it works. The hard stops and the friction plates worked exactly how I thought they were gonna work. So let's dig into the next sub-assembly, which will be electronics. Let's first get the Arduino in. That right there. My hot pink power. The MCP 23017. Get that right there. First thing, we'll get I2C set up on the MCP. That should be it for the MCP. It's got power running to it. Here's the I2C. These three pins are pulling low to set the address. Reset's got this resistor on it. Should be good.
Hi, I'm David from Element 14's The Electronics Inside. Join me as I tear down toys, tools, appliances, modern, vintage, classics, and even some new releases just to find out what's inside.
Let's see if it works. Let's flash it again real quick. See if it resets it. There we go. Okay, access value. There it is. And that is reading such a huge number in there because I've already got it mapped. Let's change that to get the value straight out of the encoder just so we can see it. That is... Okay, flash that one more time. There we go, got zeros. And now we can see how fine that is. And one full rotation is going to take that all the way up to 128, or maybe 127. It's got 128 positions that it can be in. And it can go past that. So if you needed to do multi-turn stuff, you can do that. And then you can always go back to 0. And negative numbers as well. Pretty cool encoder. Okay, great, that works. Let's test a button. All right, so we are going to plug one of these into ground and port 16 on the MCP, because that is button 1. Let's see if this is reading. Nothing there. Nothing there. Is it all the way down here? There it is. That's what I'm looking for. So these buttons are going to work. This software is called Controllers Lite, and is just some free bit of software that sees this as a joystick controller, and then these are all of the different things that are connected to it. So pretty happy with that. I think these switches are going to work just fine because they are the same. I have to write some funny code for them, but it's connected just like a button or a momentary switch, where the way I have it set up, this is going to ground, and then each one of these goes to a GPIO pin. So when you click it this way, these two are shorted. Click it that way, these two are shorted. What else? We have the other encoder, and that's a little more complicated to set up, so let's get into that one. There we go. Okay, so when I plug this in here, is not working because this pin right here, if you can see it, is ground on this. It's A, B, and ground. But if I touch this right to it, you can see that it's emulating a button push, and that's what we wanted. And that's it. I think we're good on this part. We can connect everything else and do any other troubleshooting while we're assembling the thing, because it's not too complicated of a circuit. The most complicated part is either this or connecting the MCP, which are both not that big of a deal. And we'll get it all onto a proto board, and it'll be nice and clean. Screw terminals. So if something's not in the right spot, we just unscrew it, put it in the right spot. So let's do that next. Whew, that's done. I know it was only a couple of minutes for you guys, but it was a couple of hours on my side. I really should switch to PCBs one of these days. I don't know why I haven't. I've done it before. I just need to actually do it. At the end there you can see I ran continuity tests on all of the solder joints to make sure that there weren't any shorts anywhere. Hopefully everything will work just fine when I power it up. Okay, we have all of the main sub-assemblies completed and it's time to put it all together. This is my favorite part of every build, when everything comes together and we get to see if it actually works or not. I'm going to put it all together and then mount it to my chair, and hopefully next time you see me, we'll be testing. Pull up the software here and we can see on the bottom, we got button 1, button 2, I think it's 3, 4, pressing straight down on the hat, I believe is going to be 5, yep. And then 6 and 7, 8, 9, 10, 11, and then what was 12? Oh. 12 and 13, turning the rotary encoder here, and then press down on that is going to be 14. It's very quick. I might have to fix that because the software, whatever I'm doing, may not register with that. And then we've got the hat, we've got up, down, left, and right. You can see down at the bottom there. Down, left, shows hat 1 goes to 6 and 2, and then press straight down on that is button 5. And of course the axis, you can see high and low moving there. This software doesn't show the actual range, but maybe we'll take another look at it when I get it on my Windows computer. Awesome. Let's go test it. All right, here we are ready for a test. I've got a few helicopters set up out here, but this one's the most fun, so let's jump in that. You can see the collective here, cyclic, and there's the co-pilot collective. Let's jump in, get a better look at that. There it is. There's cyclic. There's a collective and co-pilot. And let's turn the engine on. I've got the hat switch set up for this scroll menu. Click down to select. All right, and lift off. A little bit of altitude. So some of the buttons that I have set up, only a few. I've got one for map, and I've got one set to auto hover. So I flip that. Now the helicopter, the cyclic control is going to auto. This is in a perfect position for hover. If I lower it down a little bit, we'll start to descend. This is a great way to a nice soft landing. Flip that off, take off again, and we can fly around. We get going pretty fast here. Got a lot of extra buttons on it, but the main control really is this axis to control the collective. That really makes a huge difference when flying. I've used keyboard, I've used mouse, I've used throttle stick from a normal flight throttle, but this just feels really natural. I've never been in a real helicopter. I've never flown one, for sure. but it really feels good. A lot of fine control, even though the encoder is not getting a full 360-degree turn because my 6-to-1 ratio calculation on that gearing was wrong. I think it needs to be more like a 9-to-1 to get a full 360-degree rotation out of it to get all of the data that we possibly can for finer control. But I was able to adjust with the sensitivity in game, and it worked pretty good. You can see I can get them pretty low and have fine control. My altitude, ooh, pretty close to those poles. Then gain some altitude when we need it. All right, let's have a landing here and we'll call this a successful test. Find a field over this way. Bleed off some speed. All right. Where am I? There it is. That's all we have for today. It turned out pretty good. I'm happy with the functionality and can't wait to go out and fly some more. Even though my calculations were wrong on the gearing, it still worked out just fine. Have you ever found yourself in a spot where you couldn't get a thing that you wanted and you just had to build it yourself? I'd love to hear about it. Let us know on the Element 14 community at element14.com/presents. We'll see you next time, and until then, keep making.